Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be -4, 1. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100 because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08, and as a fraction we can just times top and bottom by 100, so it would be this over 8. So now we can do the bus stop method. So 8 on the outside, and in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4. And 8 into 40 go 5. Now, it says how many bread rolls can we make? Now, we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're Z angles. So we can say that that is 135 And I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one, and the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. The way I remember what to do here is using KFC, and what the K stands for is we're going to keep that fraction exactly the same, so 2/3. We're going to change, that's what the C stands for, change that divide to a times, and we're going to flip, that's what the F stands for, the 8/7, so it becomes 7/8. Then all we need to do now is multiply the tops, multiply the bottoms, and simplify if possible, so we can actually divide top one by 2 here, and it becomes the answer, which is 7/12. The rules are that when you multiply two numbers with the same base, and the base is the big number, then all you need to do is add the powers. So we're going to do 6 to the power of 15 plus 4, which is going to be 6 to the power of 19. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number. So it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. Y is inversely proportional to x means that y is proportional to 1 over x. And I'm going to change that for an equal sign by timesing the right hand side by k. And k represents our constant. And we're told that when x is 5, y is 10.8. So I'm going to fill those in. I'm going to substitute those in to be able to find out what k is going to be. So it'll be k over 5. And we're going to be solving this. Let's get my lines in. And solve it, I just times by the bottom of the fraction. So times both sides by 5. And we're going to end up with 50.4 is equal to k. So k is 50.4. I'm going to rewrite this equation here, but we know what k is. It's 50.4. We're asked to find the value of x when y is 9. So we've got 9 equals 50.4 over x. And whenever in this situation here where we've got the unknown at the bottom of a fraction and we've got it equal to a number, what you can do here is actually just swap these around. Effectively we're timesing both sides by x and dividing both sides by 9. But it does really help us out here because it just says that x is equal to 50.4 over 9. We can just do that on the calculator and it gives us 5.6. We're going to start by focusing on the a and b, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that a is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the a or b. So a or b is in a, in b, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of 2 shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say like, I don't know, 4 corners. just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So we're asked to solve f of x equals 23, but it tells us that f of x is 10x plus 3. So all we're really doing is 10x plus 3 equals 23, and we're just doing a simple solve. So get our lines in, and we're going to take away the 3 both sides, which will give us 10x equals 20. Then we're going to divide the 10 both sides, and that just gives us x equals 2. So our answer is 2. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh. A little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So to be able to solve this, we want to factorise the quadratic. And to factorise the quadratic, we're going to look at the coefficient of the x squared and the number left on its own, and we're going to multiply those together. So that we're looking at two numbers that equal, what is it, 2 times minus 36 is minus 72. And we're going to look at the coefficient of the x, minus 21, and we're going to look at the same two numbers need to add together to make that minus 21. So what we can do is we can write out the factors of minus 72, add all of them together to find out which one adds together to make that minus 21, or we can kind of do it in our head. So I'm thinking it's going to be 3 and minus 24. Let's just check that. 3 times minus 24 is minus 72. 3 plus minus 24 is minus 21, so that's correct. I'm going to write out this expression. Worry about the equation later. But instead of minus 21, I'm going to write plus 3x minus 24x. So I'm just going to replace it for what we've just found out. So it's going to be plus 3x minus 24x minus 36. And we might find it easier if we put the negative first, and I probably should have put the negative first, but let's keep going just in case we don't put the negative first. And we're going to do both of these separately. First two terms and second two terms separately. So we're going to factorise them linearly. So I'm going to take the x out of both of these, or divide the x out of both of these. Now here, don't forget the minus needs to be on the outside. So we've got minus, and it's going to be 12. And that's going to be 2x, and that's going to be a positive because it becomes a negative. Positive 3. The repeating bracket is one of our brackets. And then the bit left over, so the x minus 12 is our other bracket. So it's x minus 12 and 2x plus 3. To solve now, we get both of the brackets equal to 0. So x minus 12 equals 0. Get our lines in. And we're going to add 12 to both sides. So we've got x equals 12. That would be our first solution. And then we do exactly the same thing for the other bracket. So 2x plus 3 equals 0. Get it equal to 0 and solve it. And so we're going to take away the 3 both sides first of all. So we've got 2x equals minus 3. And then we're going to divide by the 2 both sides. So we've got x equals, and we can write it as a fraction, minus 3 over 2, or 1.5. And there we go. When solving simultaneous equations, when you have the equations drawn graphically, the solutions are just where the two lines cross. So we've got a solution here and a solution here. So the first solution is that x is 0 when y is minus 3, and our second solution is that x is 3 when y equals 0. I'm going to start by getting x equal to the 0.847 recurring, and I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So we're told to complete the square, so we're just going to get this equation here and just complete the square for it. So the first thing I'm going to do is remove the coefficient of the x squared. So we want just x squared and so on. So I'm just going to make a set of brackets, and we're going to factorise it out of the x squared and the minus 24x. So that would be minus 8x. Then we've got the takeaway 15. Next, I'm going to complete the square. So I'm going to do this in different colour just so we can see what's happening. And to do this, we have a bracket with an x minus half of the coefficient of the x. So that'd be 4 squared. Now if we expand that, we get x squared, brilliant, minus 8x, fantastic, and then we have a plus 16. So we need to remove the 16, so we're going to take away the 16. Next we're going to expand the bracket with the 3 in. So we're going to have 3 brackets x minus 4 squared, or close bracket squared, minus 48, minus 15, and then we're just going to tidy that up by adding the numbers together, so that would be minus 63. On our graph, we're going to draw the graph of y equals 3x squared. Okay, simple. And we don't need to, it's only a sketch, so we don't need to worry about exact values, but we do know the most important thing is we know it goes through the origin, so it hits here at 0, 0. That's the important thing. Okay. Because we know that if we called that f of x, then the situation we've got here, well, it's going to be f of x minus 4, okay, because we've got the minus 4 there. So that means it will move to the right 4, okay, and it will also, we've got to worry about that minus 63 as well. And if we had f of x minus 63, we know it goes down 63. So in total, we have f of x minus 4 take away 63. That's what we have in total. So we're moving just 4 to the right and then 63 down. So instead of 0, 0, our minimum point will be at 4 minus 63. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like, and it fluctuates between 1 and minus 1, if I write a minus 1, and it goes up first of all at 90, goes back down at 180, down to minus 1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to minus 1, it will start by going down to minus 2, and it will go up all the way to 2. So we've got a nice idea of how this will look, and so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to minus 2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.